D.
How did the individual preparation go for y'all?
It was pretty good.
It was fine.
But, you know, whatever. That's pretty par for the course for me. You guys should know that. You know, I'm like, everything's hard.
I couldn't get some of the SPSS stuff, but then I got it after I watched the video. The
Right.
videos were the only way that I've been able to get through some of the SPSS. I just can't like read it and then do it and have it get the same results.
Right.
Once I watched the video and watched him like click on everything, then I got the same answers. So
Right.
good.
Oh gosh. So should we start maybe? I don't know.
How about you, Haley? You good?
Did you have any
I think I'm good.
Haley's a genius.
I know.
You're a genius, Haley.
I hope I'm good on this one. I didn't give it as much time as I give to the other ones. So
I didn't either. So I'm hoping.
Agreed. I didn't know either.
Bad. Oh gosh, I'm so bad. Okay. So let's see. I'm gonna
Okay.
really hard.
Three. I think it is.
Yeah, so null hypothesis is that it equals 0, and alternative is that it doesn't.
Okay, so you said C?
C.
Okay, that's what I thought too. All right. Residual is
Observation is defined as the difference between the observed value of y.
that's what I thought.
The second one?
Yeah.
Yeah, I agree.
So the plot of residuals when doing linear regression is that there's a line, right? You see okay. Right? When the linear equation, oh gosh.
It's not when you see a megaphone.
Yeah,
Right.
it's
They don't
And
have
it's not just when it's positive.
right. I thought when you do a plot of residual supports using linear regression, then
Would it be the residuals look normally distributed with 0 mean? Or you see a pattern?
yeah, I think so. What notes is that once you've calculated an observation for every number in the data set,
right.
you use it to see the results.
So that's looks normally distributed with a 0 mean. Right?
Yeah.
Okay.
Is that what you're saying, Haley? D.
0 mean.
Yeah.
So, yeah. Yeah.
Okay.
Okay.
Okay, because it says there should be no pattern in the residuals, and I don't think it has anything to do with them being positive or negative, so I think that's right.
Yeah.
Okay, I'm on board. Sorry.
You're good.
Okay, so now we have to get into the SPS next.
Computer residuals. I feel like there's so many steps involved in these ones.
I know. Me too.
Just
Okay, so the first thing we do is the regression, the linear thing, right?
right.
So what is linear dependent? What are we finding here?
It says in the problem.
Oh, it did? I totally didn't read that.
It
Thanks.
says use the confidence data as an explanatory variable and the score data as a response variable. So the score is going to be on the y-axis.
So score is the
That's dependent.
Dependent.
Score
is
is dependent.
And what was the confidence rating name? Is the independent? Is that what it said?
yeah. Yes.
Okay, I'm going to click my confidence intervals also.
Okay, so we put those in the boxes, but then what else do we press on that?
We go to statistics.
And you have
Underestimate flat confidence intervals, which we may not need, but I'm going to click it anyway. And then under, yep. And then under save,
oh, we gotta okay. And
predicted values unstandardized and residuals unstandardized.
Okay, that's what I got.
Okay, now what is the question asking for?
And now we have to say what statement best describes the residuals. All residuals.
Okay, so I have negative 38 and 23, so I have that the residuals are between negative 40 and 25. But
Right.
we really don't know what the pattern is yet because we haven't done that part.
Right. And the residuals are not all negative. Guys, stop it. So A on that one,
Yeah, I don't know.
we have to do a QQ plot.
That's my guess.
Is
What
next.
kind of plot do we make?
QQ plot. So this one,
So do you go?
you go into the descriptive statistics Explorer.
Gotcha. I'm there. I had just written it down. And then we have to put unstandardized in the dependent,
The residual, yeah.
unstandardized residual into the dependent, and there's no factor.
There's no factor, right?
Right. So then this. Okay, and then the plot. Okay.
Normal plots with S, right?
So normal QQ, it looks normal to me. What do you guys think?
Yeah, it looks normal to me.
They're fairly normal.
They're fairly normal.
Okay. So then we need to do a scatter plot for the next one. Simple. And this one we have to do the unstandardized residuals.
Yes.
And then the headline, or no, the score. No, confidence rate.
Was it the score?
Was the
Or is y-axis?
score
The
is
y-axis- Isn't the y-axis the unstandardized residual?
yeah, y-axis is standardized, yes. But then you have to put the x-axis in. What did we have that in? The score was down there, or was it confidence rating?
Confidence rating.
Okay.
So the unstandardized residual is the y, you said?
Yes.
Yeah.
Do we have to mark anything on this one?
I don't think so.
No.
Okay.
Okay, so it's scattered pretty evenly, so that meets the requirement, right?
Yeah, it does.
So yes. So crap. So then there's
Well, we already did the QQ plot.
the residuals are normally distributed. Oh crap! What do we? Observations are x factor measured by error. Oh gee.
What's the difference between the residual plot and the scatter plot? Because
the scatter plot will show like the hot dog shape. It'll show the correlation. The residual should be scattered all over the place.
Okay.
Mm-hmm.
And then the Q2 plot shows.
Right.
You know what I'm saying?
So are we marking all of these?
Are we marking all of them?
There is a linear relationship between x and y.
Right.
Okay. They're normally distributed because they were scattered evenly.
Right.
The variance of the error term is constant for all values, which that's our residual, and it's fine as long as there's no megaphone shape.
Right.
Mm-hmm.
The x values are measured.
And those two can't really be checked, right?
All 5?
The last one can't be checked, right?
Right. Neither can the x's are fixed.
Okay.
Wait, which one's x and 6?
Number 4.
Are measured? The x values are measured without error.
So they're all good. Do we say they're all good, or do we only mark the first 3?
X value. I don't know. This is where it gets tricky for me. Okay. So the x's are known constant. Those cannot be checked directly. They need to be measured with total accuracy. Observations. Hang on. So I'm looking at my homework part.
Uh-huh.
So it says in the one, that the last two, the x's, they can't be checked directly. You have to go back and measure them. So if we're just looking at the scatter plot, residual, and QQ plot, I don't know that we can check them. Do you know what I'm saying?
Yeah.
And I think the last one's the same.
Mm-hmm.
So you're saying you don't check the last 2?
I don't know, Haley, what do you think? I don't think we marked the last 2.
I don't know, because we assume that they are, but...
You assume.
Right, we're assuming, but we can't check them.
Right. And I think the other ones are directly linked to the scatter, QQ, and residual, but the other ones you have to go back and measure them. And then the observations are independent. It says knowing the value of y tells you nothing about any other hint. So.
Okay.
So just the first 3?
At this point, one question and then everybody.
All right. No, but I'm going to say just the first 3, but
Okay.
I may lead you astray. All right, so now we're looking for the slope.
Yeah, what's our slope? I don't remember.
Find it. Oh, we have to go back into regression, right?
Yeah, where is it?
The slope, isn't the slope the second number?
What?
Hang on. So is it 0.728? Is that the standardized coefficient? Beta? Do you see what I'm saying? Under the coefficients, is that what we use for that D1?
Oh, yeah. I don't know. I can't remember.
Let me look. I've got my thing pulled up. B1 times. So Y is going to be the constant.
Mm-hmm.
Right? So Y is going to be the 18.690. So is the beta 1, or is the B1 12.695? Or is it the 0.728?
We will test if the true slope is different from 0. If the slope equals 0, then the regression line is from that. So,
well, it's 12.695 is really steep, like vertical, more vertical, I guess, and then 0.728 is like really low horizontal.
Right.
So,
you think it's the 12.695?
well,
I think so. I think it is.
You think it is?
The information related to the slope is given in the second row of the coefficient table.
So B, isn't the big, like, isn't the lower case B the B and then the weird B the beta? Do you know what I'm saying?
Yep.
So then it would be the 12.695, right?
Yeah.
I think that's right. Oh, geez.
And then the confidence interval for that
is going to be 10 point.
So yeah, my data is different.
Mine is too.
10.674 and 14.715.
Yeah, mine's the same.
So should we go with the first one?
The A?
That's really close.
I would think. That's really weird. But that's the closest one. Yeah, but then
they're all it's all different though. Like, I don't think any of those numbers are going to match what we have.
Yeah, and I noticed that in the homework, mine was slightly different too, but then I went back and looked and it said SPSS is this answer.
Yeah.
Okay.
No, I think that's right, and I think that confirms our slope because
Right. I think
the other confidence intervals don't even match the 0.728. So
yeah,
we're good on this too.
So 9. Wait. What did you put for 9? You put the 12.695.
Yeah.
Oh, okay. Good. All right. So then we reject.
I would say yes.
Because the p-value is less than A.
Oh yeah, test statistic is 4. Right. Wait, but we don't do it off the test statistic. We do it off the sigma.
Yeah. And it's 0.00000.
Reject the null because the p-value is less than. So it's going to be B, right?
Yeah, that's what I think.
Yeah, I
Right.
agree.
Okay. So then, for a hypothesis of B1, you reject the null.
So we're saying
Sufficient evidence to conclude.
the null is that it is equal, and we're rejecting that.
Right. So it would be the third one.
C,
Sufficient evidence to conclude that the slope is not there.
Right.
Not 0. Okay.
The dependent is the body length, or the head length. No, the body length.
I think it's the body length.
It is the
Yeah, I
body.
think it's body length.
So is this B? Oh wait, there's sufficient evidence to conclude B is not equal to Z. Is it A? Since it,
Yeah, I don't know. That seems weird. That was my first thought was A.
since it, you think it's A? I think it's A too.
So it's not equal to 0.
It's not
That
equal.
makes sense. There's a slope. That's not 0.
Right.
I'm pretty sure.
This was a hard one.
Yeah. I don't like the way it's
Well,
worded.
it's not C,
It's not C for sure.
Right.
and it's, let's see,
But I don't.
and it's not B.
It's not B. Yeah. Right. It's got to be A.
Okay. Ooh, we did it, lady.
I was not expecting that.
I was not expecting that either. Holy
That
cow.
was harder than we've had before. So.
Gosh.
I
Okay.
think I'll always see the score before I do. Makes me nervous. It's like
I know.
my computer's slower.
Okay.
Okay, great.
Awesome.
Perfect. Okay, so are we meeting tomorrow to go over our...
Probably. What else?
That would be great.
Because we have to have in the group project. So I'm doing make influence and take action this week. And then
Okay.
we have to put a PowerPoint presentation together.
Okay.
So do we need to,
Send the information and I can do the PowerPoint.
who's doing the power? Are you doing PowerPoint work?
I think both Haley and I have our names down on it and stuff.
Okay, so I'll just, let me send you the staff, like my graphs
Yeah, that
and
would
my
be great.
stuff like that. I'll send that to you. Okay, and I'll make the influence and take action. Oh gosh. And I'll send that to you guys before. But yeah, we probably do need to meet tomorrow to go over the homework for 24.
And then we can just, I think we can do that on Google, where we can open up a PowerPoint and just work on it together.
Right, that's a good idea.
For sure.
Okay, awesome. Cool, lady.
Thanks for all your work, though. You're doing awesome, Gretchen.
I'm like so worried we're gonna get a percent off on that.
You're not. You're doing so much work. I feel bad.
I gotta figure out the mean, because if you do the chi-squared, it doesn't give you the mean, it just gives you the F number,
Oh, yeah.
like statistic, and no. So, right. So I'll work on that. I'll get it sent over, and I'll look at that PowerPoint you sent me, Heather.
Uh-huh.
I do that.
I was just looking at it again. I don't think they have a mean on there.
Okay, I don't think this one needs a mean because we're comparing.
So their hypothesis test, they have the chi-squared test, and they have their expected count,
Right.
and then they have their test statistic and their p-value.
Alrighty, I'll send it over to you, ladies.
Okay, what time tomorrow do you guys want to meet?
Yeah, what time?
1 o'clock would be fine. I'm pretty free tomorrow.
That work for you, Heather?
Yep.
Okay. All right, ladies, we'll see you tomorrow.
Okay, thanks.
And thank you so much. Have a good day.
Yeah.